We're on the road.
We're on the road.
Yes, Cosmos on the
location.
road.
Yeah, that's how
We're on tour.
That's how we roll.
It's a one-stop tour, but it's a tour.
Ooh, Katie has a berry banana smoothie. That sounds delicious. I like that.
All
All right. Wow. It's we are currently hanging out in Bend, Oregon, at my parents' house.
Sold out show
Today.
Live studio audience, kind of.
And on this episode, we are featuring the art of one Katie Davison, or Wild Ixia. Buy her shit on Etsy. Wild Ixia, Wild Ixia. This is some of her old stuff. In fact, we did a art planetarium show with this piece right here. It makes really good full dome kaleidoscope.
Yeah. So I think I just put Den in it.
Oh, and Jack has pointed out, is that a new tattoo, Mike?
It is. It is a new tattoo I got this week of Saturn V rocket, which will eventually,
blast
hopefully,
off
complement
into the solar system.
Eventually into the solar system up here. So.
Hi, Mom, who's downstairs right now. Oh, it seems a little laggy on Katie's end. It could be the internet's not the best in Bend, so just
We're everybody's
bear
pulling
with us.
the internet.
Yeah, it's all my dad's golf is just no. Okay. Well, you wanna? Am I hosting?
Yeah.
I'm hosting. Okay, cool.
Because I hosted last time.
I'm hosting, but he's
this?
got all the information. So here we go. Get ready, set, and. Hey everyone! Welcome to another episode of Cosmos with Cosmos. I'm Liz.
I'm Mike.
And Brandon is on the road again.
On assignment. I think he's in New Jersey.
I don't know. He's
either in New Jersey or on his way to New Jersey.
Yeah. Anyway, this episode, we are talking about dark matter.
Dark matter.
What is it? It's weird. Phancy Physics Man is going to get super excited and nerded out during this episode, and I am here for it. I can't wait for it.
There's so much to it.
I know.
And we don't know anything about it.
I know, it's great. But first, follow us on all the things at Drinking Cosmos on Twitter and Cosmos with Cosmos everywhere else. Yeah. What you drinking?
All right, well, it's kind of...
Oh, jeez.
It's kind of pointless now.
You can still see it. You can still see it.
You can still... Oh, yeah. There it is. All right, so I am calling this... I actually have... I have a couple drinks, but this one is basically... I'm calling it the Vera Rubin.
Aww.
In honor of Vera Rubin, an elegant drink for somebody who should have won the Nobel Prize. It's an old-fashioned. So to Vera Rubin.
To Vera Rubin.
Cheers. And dink.
Smoke smells good. It makes me think of Christmas.
And I smoked it with, holy crap, that's really good. The bourbon is a blackberry bourbon, and I smoked it with cherry wood.
I want to taste it now.
I have purchased a smoker, and I just am really happy about using that. That has got some sweetness to it.
Ooh, okay.
That is...
All right, that beats my drink. My drink is All That Matters is Dark. And it is basically what's called a grown-up lemonade, and I can't remember what's in it, but lemonade and things. Frozen dark cherries.
It's got dark cherries in it. Dark cherries blended with lemonade and cherry vodka, and I think is that it? I think that might be it.
I don't know.
No. Oh yeah, simple syrup's in it. That's right. And you put it in the blender, you blend it up, and pour it over ice.
Mm-hmm. Refreshing. Jack has a cayenne orange and white chocolate latte, and I bet it does smell amazing. Oh, man.
Yeah. And what does Katie have?
She has a berry banana smoothie.
Oh, nice.
Which also sounds good.
It does.
Yeah.
It does. It's a little warm. I've been running though.
You have been. Do you want the fan on?
No, it's all right.
Okay.
I'll cool down. I was running making drinks, and then I got up here and forgot my iPad was not up here.
Well, you relax while I go over the rules. Of course, we have some drinking rules, or I guess it's kind of a game, but drinking rules. If you hear some dogs, the dogs are with us on location in Bend, Oregon. So if you hear them barking, take a drink. Maybe if you hear a cat meow, add a little extra spice, because Winter is also with us in Bend, Oregon.
Whole family goes.
A whole family goes, so take a drink as well. And then if we mention any Star Wars or Lord of the Ring references, also take a drink.
Cheers.
Cheers, but for now, black holes. Or no, wait, what are we doing? Dark matter.
We'll eventually get there.
We'll eventually get there. Dark matter. Hey, what the fuck is it?
Okay, so that's kind of a loaded question because we don't really know what is it. We know it's there. And so
Could it be aliens?
What?
Aliens.
Well, maybe. So dark matter is called dark because it doesn't really interact with the electromagnetic field. So what does that mean? That means that it does not emit light. So it doesn't radiate like stars. It doesn't reflect light. So not like planets. Planets reflect the light from stars, and moons do that as well. And it does not absorb any light. So it doesn't interact with light in any kind of way. The only way that it interacts that we can see with the universe is gravitationally.
Oh.
So in a nutshell, that's what it is. That's a really broad statement, though.
It's just a gravitational interaction? That's...
Yeah, pretty much. Pretty much.
It's an essence of gravity?
Yeah. For the most part.
Gravitational essence.
So I tell you what, why don't we just say what it isn't?
Oh, okay. That seems like
So
a long list.
All right. Well,
most everything.
I got four things on here. So we know that it's not stars or planets or moons or asteroids.
Because we can see those.
Because we can see those. They either are emitting light or reflecting light, that kind of thing. So we know it's not that.
Which begs the age-old question: if the moon is reflecting starlight, how come a full moon doesn't turn vampires into ashes? Age-old question. Just putting it out there.
I think that is a beautiful hangover question.
All right.
I mean, I'm pretty sure the hangover is just going to lead to some crazy stuff. So we know it's not that. We also know it's not dark clouds of normal matter.
Okay.
So
like
hydrogen,
nebulae?
helium clouds.
Like dark nebulae?
Yeah, so dark nebulae, that kind of thing. The reason why we know that is because these clouds can be detected because light passes through them and absorbs.
Okay, yeah.
And they absorb light.
And that's why they're dark, is because they're actually just absorbing the light.
Yeah. Now, in physics, there's kind of a little bit of a distinction when we say dark clouds. We're saying these clouds are made up of things called baryons, and baryons are going to come
Can
up
you make
really kind of bit.
a berry on banana smoothie with them?
I can tell you that berry banana smoothie is filled with baryons.
Oh, okay.
Trillions and gazillions and bazillions of them. Because baryons are just fancy physics words for saying protons and neutrons. These are objects that have 3 quarks in them.
Okay.
And these are objects that interact with the strong force.
But you only need 1 Ferengi to make a quark.
Too bad Star Trek's not on the drinking. You know what? I'm gonna take a drink to that.
Take a drink of that one. That was actually. I'm pretty proud of that one.
That's worth it. That's worth it. We also know it's not antimatter, because with antimatter we can see that when a particle runs into its antiparticle, they annihilate each other into gamma rays. And so it'll create a little gamma ray flash, and we're not seeing that. So
no fireworks.
No fireworks. We know it's not antimatter. We also know it's not supermassive black holes, because if it were supermassive black holes, just kind of floating around out there in the universe, we would see a lot more gravitational lensing events than we're seeing.
Oh, okay.
And Though we see some,
because those are like the big boys of gravity.
Those are the big boys.
Those are the heavy hitters.
Those are the heavy hitters, and they are not creating the gravitational lensing in the numbers that we would expect to see.
Gotcha. Oh, is it space bacon? Jack wants to know.
Is it space bacon?
Space bacon.
I like it, yeah. Let's say it's space bacon.
Space bacon. Yeah. I made bacon this morning and it was delicious.
Oh my gosh. Man, I don't think I need dinner tonight. I'm going to eat dinner, but I don't think I need dinner.
Yeah.
That's probably why I have the girth.
Just have some space bacon.
Huh?
Space bacon.
Space bacon, yeah. So since we don't know what it is, I mean, right now we need to kind of rule out the things that it's not.
Okay, yeah. To narrow down to something we don't even maybe have a word for yet.
Yeah, pretty much. I mean,
can we just make one up? It's glipflarb.
Yeah, when they spell that, don't spell it. Yeah. So I mean, that's what we need to do, and eventually you are going to get down to a list of objects that it could be, and we do have some possibilities,
some candidates.
Okay. However, the evidence isn't panning out for some of them.
Go through further interview process.
Yeah, we need to expand the search a little bit in this. So I guess the question becomes, how do we know they exist? How do we know dark matter exists?
Yes. Well, I mean, we can see its effects. We can measure its effect. See is a bad word. We can measure.
Can measure its
effects. We can measure the effects.
Yeah, and that's great. Yeah, because you can't see dark matter. Which I think is crazy, like when you're watching Star Trek and things like this, and they talk about dark matter, and especially this dark matter anomaly, which is 1,200 years into the future. It's just
they're still using dark matter. It's like you should have a.
At that point, they've just given up naming things. We know what it is. We're just gonna call it.
When we figure it out, do you think we might actually just keep calling it dark matter, just because it's been known as dark matter for so long? That
I doubt it. I mean, I think, I think that.
So basically, if we end up finding out what it is, we can measure it. So if we find out what it is it basically kind of like a dispersed collection of a certain unknown particle then that we don't know of? So it would just be we would call it whatever particle.
Yeah, I mean, possibly. I mean, particles, they are looking for particles.
What are the candidates?
All right, well, let me move on down to my list here. All right, so right now, you can kind of break it up into two different camps. Baryonic matter.
Ooh.
And non-baryonic matter.
But it doesn't, but the baryons react with stuff, but it doesn't do the baryonic thing.
Right. So one of the thoughts was that it could be this thing called machos, which means massive compact halo objects. And these are things that would be in the halos of galaxies and stuff like that.
Would globular clusters?
No.
Okay.
No. Remember, these are things you can't see.
Oh, okay, yeah. We're talking quantum.
Well, no, these are actually big things.
Oh, okay.
These are things that you could actually run into and touch.
Oh.
The problem is that, all right, so these could be tied up into brown dwarfs, neutron stars, black holes, white dwarfs, clouds of heavy elements, things that are typically very hard to spot.
Okay.
So if you have a black hole that's just kind of sitting out out in the halo of a galaxy, so outside of the galaxy, kind of by itself, doesn't have anything going around it, you got no gases falling into it, you're not going to see it.
Okay.
But this is baryonic material. And so white dwarfs, very hard to detect. Basically what they're saying with machos is that, hey, all these things that we can't see, that are very hard to detect, it could be dark matter. But it's just not lining up for machos. The evidence isn't
I feel like we would be able to then see what it was if it was machos on that scale.
Yeah, and I mean exactly. And again, the evidence against it would be that these baryonic clouds, these clouds of hydrogen, helium, and other stuff, they would be backlit by distant stars for one thing. You would get absorption that comes through them, and
we don't get any of that interaction.
And we're not seeing any of that. Also, if you had all of this extra stuff, Big Bang nucleosynthesis theory. So
Wow,
the Big Bang creating hydrogen, helium, and lithium.
Oh,
and that
okay,
kind of
okay.
stuff. We would actually see different abundances. Big Bang nucleus, the Big Bang. I gotta look at it. Nucleosynthesis theory is really amazing at predicting the abundances of like hydrogen, helium, lithium, and all that in the universe from the Big Bang itself. And so, if you have this baryonic matter that is dark matter, then it is. We would see different abundances of hydrogen, helium, and lithium in that.
Okay.
So
we're seeing what we should be seeing.
We're seeing what.
But then there's something weird happening that is still like, wait, what?
Mm-hmm.
Everything looks correct except who's that guy in the corner? Where did he come from? Who invited him?
Gravitational microlensing. So this is gravitational lensing, but kind of small. Found a very small fraction of dark matter that can be in the form of machos. Very, very tiny. So maybe some aspect of dark matter are these machos as it's being laid out in here, but it's a very, very tiny percentage. So it's not a lot. It doesn't significantly contribute. And the cosmic background radiation implies that 5/6 of the total matter is in the form of matter that interacts only gravitationally with ordinary matter and doesn't really do anything with the electromagnetic field. So the cosmic background radiation is kind of ruling out these machos.
Oh, okay.
Yeah, and so the current view is that it's really nothing.
It's not machos.
It's not machos.
Hey, machos, get out of here. It's not you.
All right, so kind of associated with this, and I found this in my research, and I hadn't included this.
Is it the opposite of machos?
No.
Oh,
That's coming up.
Oh, okay.
These are robust associations of massive baryonic objects.
What?
Rambos.
Rambos in the universe. Universe Rambos. There can be only one. I'm mixing references, but I don't care.
Yeah. So these would be dark.
Wait, can we say it a little bit slower for those?
Robust association of massive baryonic objects.
I feel like they started with Rambo, and they were like, let's make this work.
Yeah, somebody watched the movie.
Yeah, Steve's like, I got it. Rambo. And they're like, all right, huddle up. What do we got for ours?
This work. We got to make it work. Yeah, because robust just seems like it's
robust. Like it's not a normal descriptor of a universal object.
Then they're like, this is probably, we have an association of these baryonic objects, but they're kind of massive. We have an association of massive baryonic objects.
They don't like ambos.
Ambos, that just doesn't work.
Let's make it cool.
But,
we already got some machos.
But why don't we say it's a dark cluster of these things, of these dark brown dwarfs, and then we could say robust and make it a Rambo.
Yeah.
Yeah. All right. So.
Sylvesters. My mom just says Sylvesters. We got some Sylvesters out in there in the universe.
Yeah. So the collection of brown dwarfs are Rambo. It's called Rambo, but the individual brown dwarfs are Sylvesters.
Oh, I like that.
Or whatever movies he's been in. Rockies. Yeah.
No, I like Sylvesters.
All right, so that's basically about it for baryonic matter. And again, nobody thinks it's baryonic matter.
Okay, so basically the baryonic matter camp is like, it's like,
Yeah.
But it's like a cult that's got like one person left in it, and that's just like, guys...
Yeah,
I got
it's not.
Kool-Aid.
It doesn't have a lot. It doesn't have a lot to it.
Okay.
But back in the day, and when I say back in the day, we're talking about 90s, 80s, and 90s.
Oh, okay. It's way back in the day, man.
Yeah, that was one of the things.
Okay. Yeah, but I mean, we didn't know a lot.
All right, so no, we didn't. No, we didn't.
All right, so non-baryonic.
Non-baryonic matter, so matter that does not have quarks in it, matter that does not utilize the strong force in any kind of way. There are some other candidates and physicists, and this is actually kind of a marriage between physicists now and astronomers and astrophysicists. Because I know, right? Because now we're delving into particle physics. And there is an example in non-baryonic matter. That's a little bit bigger, but
hold on, I gotta throw in Jack's comment here. Dreads were voted off the island of Rambos.
Hold on. All right, so here is the opposite.
Oh
of
yay!
machos.
These ones, these are fun.
Wimps.
Wimps.
Yes, these
Wimps and machos. Who named these? They're brilliant. I love it.
Yeah, I don't know.
They're having fun with it.
Physicists will have fun.
All they do is math all day, so they're just gonna throw in a little spice.
They gotta do something. So these WIMPs are weakly interacting massive particles.
Okay.
And these are particles that obviously are interacting with the gravitational force. So they are providing gravity to the universe.
They were just providing gravity. We give you some gravity.
Right.
They're very serious.
But they also could have the weak force working on it as well. And so that's where the weakly comes from. I mean, the weakly is going to be it has kind of two meanings to it. It implies the weak force.
Aren't the weak forces like the stronger forces, though?
No, the weak force is actually.
Okay.
So
I thought there was I thought it was like opposite. Like it was.
No, in particle physics, the weak force is responsible for radioactive decay.
Oh, okay.
That's
pretty strong. Chernobyl.
Right, but what they had discovered first was the strong force, which actually is the strongest force in the universe. Okay. It's just it operates on a very small scale.
Strong bad force.
Yeah, and so it's what keeps atoms together. Well, it actually keeps the nucleus together, I should say. Okay. And it limits the size of a nucleus. So you couldn't have a nucleus that has 1,000 protons and neutrons.
Okay. So it's a little regulatory component.
Yeah.
Okay.
Because what would happen is, so you have all these protons that are packed close to each other. Mm-hmm. They are trying to repel each other. Mm-hmm. But they're feeling the strong force, which keeps them bound together. Yes. You get to a certain size, that repulsion from the like charges will just blow apart the atom. So the nucleus, and so you get to a certing size, and it's around. I mean, obviously we have more than 100 atoms. But when you're getting up there, those atoms do not last long at all.
Oh, they're kind of like a boop boop.
Yep.
Is that why like the Higgs boson is like?
No, that's different.
Oh, okay. Yeah, anyway, moving on.
Yeah. Whoops. There we go. So these particles interact only with gravity and the weak force, or maybe something weaker, which implies maybe new physics. That's
new
going on.
physics. I mean, but once we figure out what dark matter is and dark energy, isn't that going to be new physics basically, or is it just going to be physics that it's still same physics, but just like a little extra thing we didn't know about it?
I think it's going to be new physics.
New physics.
But that is somebody who is way far removed from the inner discussions of what this
like
new
you're a
physics.
fancy physics man.
Yeah, but they don't let me in their team huddles.
Oh, you don't get to go to the meetings.
I don't get to go to the meetings.
Okay.
And it's also kind of a hopeful thing because I really want some new physics.
Yeah, you always want like new discoveries in science and new things because it keeps.
Yeah, and
keeps things
you know
fun.
what? At the end of the day, there has to be new physics. Because your two pillars don't talk to each other. General
Oh,
theory,
we need a
relativity,
bridge.
and quantum.
We need a bridge.
Yes, you need some. What all do I have on me? Cause
No,
you
it was
have
just
been-
like a little eyelash. Then he had like a little, I don't know, eye crusty on your hand.
I feel like I'm covered in stuff now.
I'm cleaning you. I'm just grooming you.
And I had a shower. And so since we don't know, we have not discovered these weakly interactive massing particles. I mean, we're looking for them.
We haven't discovered the WIMPs?
No, we have not discovered them.
Oh.
We haven't discovered
They're hiding
any
from
of
those
these.
machos.
They are. So nothing has detected it, but they think that these particles would be in between 1 and 1,000 times heavier than a proton.
I mean, that means nothing to me.
Yeah.
My mom asks, is dark matter all over space? Yes. Well, I mean, yes. But it's concentrated. Is it concentrated in certain areas? Like with galaxies and stuff? Or?
Well, yeah, I mean, if you look at the universe, if you look at a map of the universe, you see these filaments and strands. And so the dark matter is concentrated.
That's a cosmic web.
It's a cosmic web.
It's a cosmic web.
And so
I don't know why I forgot that.
Yeah, so you'll see these filaments that reach out through the universe. And this is where the galaxies line up on.
Yeah.
So think of dark matter
like
as the lattice in which the galaxies cling to in the universe as the universe expands. But outside of that lattice, you have voids where you don't find
of
much.
Complete nothingness.
Okay.
The nothing.
Yeah, and like you'll find dark energy. There'll still be some stuff. There'll still be stuff there.
Jack says for the bridge physics, they should name the dark matter as zip lines. Parentheses lines.
I like that. It's good.
Whee!
So dark matter is there, but it's pretty much predominantly concentrated in these filaments and webs. There are experiments that are looking for them.
I'm guessing using like colliders and stuff.
Not so much for the WIMPs.
Oh, okay.
For WIMPs, what they're doing is they're setting up these huge vats of xenon, and the dark matter part of the WIMPs will come in. They'll hit the xenon will flash, and so they're looking for these little flashes. And we have experiments like that going on in the U.S. and.
Brandon just hopped in. Yeah. Represent.
He could have Skyped. Anyway, so what was I saying? Oh, U.S., Italy, and China have the xenon. Things going on. But there's also some others like using germanium and argon.
Xenon. Warrior physics.
All right, take a drink.
Drink for that, because...
What did we listen to? Oh, she was on the Tig podcast.
Tig podcast. Don't ask Tig.
Yeah, don't ask Tig. It was great. So there's also things called axions, which are particles that are hypothesized in 1977 to explain kind of an issue that quantum physics is having.
Okay.
If the axions are cold, meaning that they aren't moving fast, then they could be a possible dark matter solution.
Okay.
The problem is that and this is the problem with everything, we have not discovered it yet.
We haven't found it.
Yeah, and so the Large Hadron Collider.
Okay, so.
Has been looking, and
colliding things.
Yeah, colliding things, and you look at what comes out.
Smashing the tiniest shit possible together.
Yes, and it's basically a huge train wreck, and all this debris comes out of it, and you look at the debris, and you're able to figure out what kind of particles these are, and the characteristics and properties of these particles, and they just have not been able to find anything. That is really what they're looking for. They're not specifically axions, but they're looking for things. They're looking for particles that supersymmetry would, which is like the next thing up. You have the standard model, and this is kind of a.
This is like honors physics.
This is honors. This
Honors
is honors
quantum?
standard model.
Honors.
And it's not finding anything for this for supersymmetry.
But look how long it took to find the
Super
Higgs boson.
That is true.
I mean, how many times did they smash shit together to finally get one little like boop?
Well, they got more than one little boop.
Okay,
but,
well, you know, I mean.
But yes, but they aren't finding anything in the collisions.
Wow. Do we need? My mom points out. Do we need new technology, like in
Maybe.
order to find it? Like we just can't smash
Possibly.
it. We can't smash bros fast enough.
Maybe, but those the Large Hadron Collider, it's got everything going really fast. And so, I mean, sure, we could always use more energy. And to collide these things and see what comes out and maybe, but the higher the energy is going to imply these axions or a higher mass. There's nothing wrong with that.
Yeah. Okay.
But you know, we'll see.
No mass shaming particles here.
Another potential non-baryonic thing are called sterile neutrinos.
Oh no!
Can't have little baby neutrinos.
Oh, that's sad.
These are hypothetical.
So these are just like maybe.
Yeah, no, we haven't seen any evidence of these either.
Okay.
These would interact only via gravity, and not of any of the other forces of the standard model.
Interesting.
And again, and sometimes these are called right-handed neutrinos. I can't remember why.
Because they're shady, like right-handers.
All the what they call active neutrinos, so regular neutrinos,
Or left-handed.
Yeah. And I can't remember what the left and right-handed mean with neutrinos, but these are sometimes called right-handed neutrinos.
Okay. That would be a weird thing to explain to an alien species that doesn't have hands.
Yeah, I know, right? How do you do that? So, if you're talking to the dark matter anomaly, how do you do that? So their masses have yet to be determined. They don't even know how to figure out the mass.
Do the experiment to find them?
Right.
Wow,
And
okay.
so this is, the 2018 mini boom experiment show potential evidence that there was, but then 3 years later they didn't find it again. They didn't find it.
Oh, wow. You need multiple data points, so.
You do need multiple data points. One data point doesn't mean anything because that could be
That's like
an error.
the one data point that life exists in the universe. It could be an error.
I gotta tell you, the way things are going, it's an error. It's a complete error.
I didn't know you were going to say error when I started my...
The world is...
But I'm sticking with it.
Yeah, and no, I'm with you. I'm with you. Have you seen the news lately?
Yuck. No, let's not. It doesn't get better.
The two big news items of the week are just fucked up.
Yeah.
Completely. All right, so... and then finally something that would be non-baryonic matter but is not on the micro scale are primordial black holes.
Ooh, primordial black holes. So like ancient, old.
Yeah, these
black holes.
And these are hypothetical. So we don't have any evidence of them yet.
But again, wouldn't the gravitational lensing? Or are they just so small?
No, these are
really
it kind of
small
depends.
black holes that are
so hypothetical
everywhere.
So these formed shortly after the Big Bang.
Okay.
And
okay.
These did not form from stars collapsing.
Oh, okay.
These formed from regions of space and time being dense enough to actually create the black hole.
I mean, that's a heavy region of space and time?
Yeah.
What does time have weight to it?
Well, space and time they're connected. So
space-time. I can't. My brain, we're getting into a realm where my brain starts to, I feel it getting a little squishy right now, so.
Yeah, well, yeah. All right, but here's the thing. So since these did not form from stars collapsing, you do not need stellar mass to create this black hole.
Yeah.
It could be, you could have the mass the size of a mountain that can make this black hole.
Wow.
because you're just talking about dense regions
Yeah.
of space-time. So black holes with masses of about 100 billion kilograms, small mountain, and I could not find it, but I was looking for the mass of Mount Hood here in Oregon because I'm thinking it's going to be about that size.
Can you measure the mass of a mountain?
Oh yeah.
Okay.
Yeah, I mean,
don't know.
you can figure out how much volume the mountain takes, especially
when does the mountain begin and the rest of the Earth end?
I don't know. You have to ask a geologist on that part, but
we will explain in a minute how we can measure dark matter, what the effect is that we've seen. We didn't
is that a question?
Yeah, we didn't explain that at all.
Okay, we can do that.
No, we'll do that in a little bit.
All right, so these Mount Hood-esque size primordial black holes should be evaporating from Hawking radiation like right now. So we should be able to see basically gamma ray flashes.
Okay, but if those are the dark matter, what happens with them all disintegrating right now?
Dark matter goes away.
But what
in a flash of gamma rays.
What happens to just the galaxies? Are we all going to stay put?
Well, no, I mean, the galaxies at this point.
Okay, so it's not like it's dark matter that's holding everything kind of together.
No, not really. No.
Okay. I just think, the cosmic web. It kind of just makes it.
So,
it gives an impression that.
All right, we'll get that in a second. All right, so the Fermi Gamma Ray Observatory has set the limit to less than 1% of dark matter being primordial black holes.
Oh, that's not big. That's not big.
Yeah.
So
we have.
So what you're saying though, but dark matter then could be multiple things.
It could be multiple things. Probably it's predominantly gonna be something though. One thing.
Okay.
But you're gonna have a lot of other things contributing to it. Mm-hmm. I mean, you will have, let's say, primordial black holes exist. You will have them contributing to it. Mm-hmm. You'll have brown dwarfs.
But if we find out, like, say, dark matter is one thing, then that's dark matter, but you just have, like, then these primordial black holes are just adding to, like, the mass of, or whatever.
Right.
So they wouldn't be, like, the same thing.
Yeah, so the... I don't know why. There we go. No, I don't know why my iPad has all of a sudden gotten really small. Anyway, so how do we know that?
How do we measure it? Like, what were we like? Wait a minute, there's something else here. There's something else that's doing something.
It was first hypothesized. By Lord Kelvin.
Lord Kelvin.
Yeah, there we go.
Responsible for the temperature of the universe.
Well, yeah, kind of. I mean, he did a lot with.
Is it the Kelvins? Where do we get Kelvins from? Lord Kelvin?
Yeah, because he did a lot with thermodynamics.
Oh, okay.
Lord Kelvin stated in 1884 that many of our stars, perhaps a great majority of them, may be dark bodies. That was the first hint of somebody saying that there might be this dark matter out in the universe.
Oh, but why? Because we can see them.
Right, but also, though, I think he's using stars very loosely here.
Okay.
Meaning anything that was up there.
Is he being a little philosophical with it?
Yeah, I think so. Because I think
poetic with it, as they were wont to do.
Right. But I think what he's doing is he's looking around and we have the sun. We also have the moon. We have the earth. We have all these planets and asteroids. We've known about comets by 1884, obviously. But and so he's saying that there's probably a lot of that shit in the universe.
Yeah.
That we would not be able to see, and hence it would be dark.
Okay.
Fast forward about 40 years. Dutch astronomer Jacobus Kapteyn.
Jacobus
Kapteyn. Anyway, he suggests dark matter based on stellar velocity. So he's looking at stars, how fast they're going, and he said there might be a little bit more matter.
When was this again?
1922.
Wow. Okay.
Yeah, so he's saying they're going a little bit faster than they probably should.
It's just amazing that we can measure like stars moving.
Well, Doppler effect at that point.
I know, but
Yeah, so 1933, Swiss astronomer Fritz Zwicky.
oh snap! It's your boy.
It's my boy.
It's his boy.
Spherical Bastards. That's a great punk name, by the way.
Spherical Bastards.
Yeah, that's gonna be my punk band name. Clay.
Yeah, that's definitely a good punk band name.
Yeah, I think me, you, and Brandon ought to make
We're
a
gonna
punk
have
band.
a punk band. He'll record from location. Jack says, if the primordial black hole is made of a knot of time, shouldn't we see more of the stars spontaneously aging when they move out in front of them?
What is that question?
If the primordial black hole is made of a knot of time,
okay.
shouldn't we see more of the stars spontaneously aging when they move out in front of them? I mean, my brain just melted, Jack, so
No.
I'm of no use to answering your question.
All right, so so the black hole passes between us and the star.
This is what he does when he's thinking really hard.
Yeah, so the primordial black hole passes between us and the star. Really what we should see is some sort of lensing effect that occurs. So there should be a blip in brightness.
Oh, okay.
However, though, my thought is no, because time is going the same rate for us. It's not. No, I don't think so.
He says no, and he's sticking with it.
I'm gonna stick with it, but I have to think about it some
That's a
more.
great question, Jack.
That
You got him to think real hard. He's gonna be thinking about it all night.
That's a brain melt question, but if we were in the black hole, then
we'd be dead. End of story.
Let's pretend that we don't die
Okay.
and that we can experience, and so we would see the star spontaneously aging, but we would have to be at the black hole.
At the black hole,
to
okay.
do that. Here on Earth, time still flows.
So it's a yes and a no.
Time, yeah, but for us here on Earth, time still flows at the rate it flows because of the gravity we're experiencing, and sort of the speed that we're going, but predominantly the gravity that we're experiencing, and so we're not going to see it spontaneously age.
Okay.
But if we were at the black hole, yeah.
All right.
In the black hole, which is not what you want to do.
No.
Anyway, Zwicky discovered an unseen mass.
Ooh.
Yes,
Whoa.
which he called dark matter.
Okay.
When he was studying the motions of galaxies in the Coma cluster. And he estimated the mass of the unseen matter to be 400 times that of the visible matter. That's off by an order of magnitude plus.
Okay, I was like, that's a lot.
Yeah, and it was based on the Hubble's constant. So the Hubble's constant was in there, but it was an older version of the number.
Hadn't been updated.
Hadn't been updated. And so as we've gotten more accurate
Data
for the Hubble,
Observations?
then if he had that number today, he probably would have gotten it right.
Okay.
In the 1960s, Seth Shostak showed that half a dozen galaxies spun too fast in their outer regions.
Oh, okay.
So about 6 of them.
Mm-hmm.
Seth Shostak actually went to SETI later on, so he's looking for aliens.
So he's like, it's aliens.
1978, Vera Rubin.
Oh boy.
Yes. She was working with Kent Ford, also Ken Freeman. They used a more powerful spectrograph to get the velocities of these stars.
Check out our Shots episode on spectroscopy.
Yep. And they found that The galaxies contained 6 times as much dark matter as visible matter, which is pretty much spot on.
Wow.
Yep. And so,
so basically, it's like, okay, we can, out of what we can see, we have this much matter. However, we're measuring a total of this much matter in the galaxy. So there's an X number here that we cannot see and are confused by. So basically we know that there's dark matter there's dark matter because there's extra mass in the galaxy that we've measured and can't see.
Right. And what they were doing, Vera Rubin, and
these
the
other
hell with
assholes.
the other whatever.
The other members of the
They don't
patriarch.
exist. It's Vera Rubin. What they were doing, and it's a crazy story with Vera Rubin. Vera Rubin, when she was going to get her PhD, she was asked what she wanted to work on. And she literally said, something that's not controversial. She wanted something that was not controversial at all. She wanted to work on just something that was bland. She was not looking to make a name for herself. And so they were like, why don't you work on the velocities of stars? Seems bland enough. And so what she did was, with others, she measured the speed at which the stars are going around the center of the galaxy. So she would look at stars that were kind of close to the center of the galaxy, measure how fast they were, and put it on a graph. And then she would step out a little bit further, measure how fast those stars were going, and put it on a graph. And what she was expecting to see, and in fact what everybody was expecting to see, was that the galaxy, the stars in their motions around the center of the galaxy, would mimic how the planets revolve around the sun. And so as you get further away from the sun, you feel less gravity from the sun. And so you don't need as much speed to actually orbit the sun. So
But isn't in that at least that law of planetary motion by
Kepler's
Kepler,
second law.
It's not about speed though, it's about time. The time it takes for a planet to orbit the sun.
Right, and so that time slows down.
Yeah.
The further out you get, or it takes longer. The further out you get. If you dig into the math a bit, you find that what that also means is that the planets actually slow down.
Oh, okay. My astronomy teacher was like, "It's not speed. Don't." I guess she just didn't want us to be confused in saying this. She wanted to use the correct term when we answer the question on the test.
Technically, Kepler's law. This was before Newton.
Yes, this was way before. This was.
Yeah. Kepler's law relates the.
Sorry, I accidentally triggered my Google on my Fitbit, and she started listening to.
What Kepler's law says, second law says, is the period of how long it takes for a planet to go around
the same
is related to how far away it is
from the sun. Yeah.
Okay. Newton comes along and mathematically formulates gravitation.
Okay.
And from there, you find out that the second law actually is a velocity law.
Oh, okay.
There's a velocity component to it.
Okay, gotcha.
And so Mercury feels more gravity from the sun because it's closer. And so to maintain its orbit, it must go faster than Venus, than the Earth, on out to Neptune, the 8th and final planet in our solar system that we know of today. And so Neptune is going much slower. So they assumed that the stars would do the same thing. So the closer you are to the center of the galaxy, the faster you must go to go around the center of the galaxy, and it slows down from there. Vera Rubin did not find that. She did not find that at all. And so what she found was that the speed at which the planets go around the center of the galaxy actually flattened the stars. What did I say?
Planets.
Oh, the stars.
Their planets.
They might have some planets. The speed in which the stars go around the center of the galaxy, if you plot it, it doesn't fall off. It actually flattens out. And so stars at the edge of the galaxy are going just as fast around the center of the galaxy as stars that are halfway out front. And that was just a mind. It was a physics. It's basically I don't like to say paradigm shift because I think of quantum physics and general theory of relativity and Newton's formulation of physics as paradigm shifts. These are real shifts in the way that we think about the universe. But to me, this is kind of a minor paradigm shift. It is. It showed that, and the only explanation for this is that there is
something that's adding momentum, that's providing the velocity for those stars.
That is adding a gravitational force that these stars are experiencing, and 5/6 of this shit, 6 times, we can't see it. And so this is the first time that we really have this. Sure, this is Wiki. He measured it with a coma cluster. 400 times. He was really off. But at least he had the right idea that there was unseen matter. But this was the first time that it was really measured accurately. And not only is it happening here, it is happening in Andromeda. It's happening everywhere. And that's why I feel like Vera Rubin should have gotten a Nobel Prize. And I realize that, like, I get all pissed off about it every time. But she really did deserve it.
Vera Rubin is your Starlink.
What?
Because Brandon gets pissed off about Starlink every time.
Yeah, that and tardigrades. But
I hope he's ranting right now, wherever he is.
New Jersey.
He just goes, God damn it.
And so, but she was very gracious about it. She was extremely gracious about it.
Of course, she has to be.
And ironically, she just wanted something that was bland and not controversial at all. It is not the only evidence that we have. For example, gravitational lensing, we see it stronger in cases because of dark matter. The cosmic background radiation is showing evidence for...
Ooh.
Yeah. So dark matter does not interact with light. However, it does affect the cosmic background radiation with and gravitation. And so the only way to explain some of these features, like the knottiness of it, is with...
not its knottiness. It's KNOT.
Yeah, with the the only way you can explain it is with present dark matter. The formation of galaxies. So the early universe was dominated by radiation, and an ordinary matter-only universe. That radiation would prevent any density perturbation, these knots of mass. From forming until much later in the history of the universe.
See it that soon after the Big Bang.
Right, and so if we look at the universe today, if it was a matter-only universe, then it wouldn't have the structure that it has.
Matter-only universe.
Right, it's the ordinary matter, that baryonic matter.
We're open to all kinds of matter in this universe,
except Florida.
Well, and Texas. The whole South. So
don't say dark matter in Florida.
My dark. Never mind. That was bad. I'm not going to say what I was going to say. So the gravitational pull of black matter shows the stars going around the sun. My mom asked. No, it shows dark matter, Mom. No, it shows that the stars going around the center of the galaxy are going around at the same velocity as stars closer to the center of the galaxy, when they should slow down based on like the physics of our solar system and what we have found mathematically using our solar system. When we do that on a galactic scales with stars orbiting the center of the galaxy, we find that there's a constant velocity there, whereas there shouldn't be. Stars further out should be orbiting slower, but they're not, and so dark matter is adding that gravity that keeps them moving at that constant velocity.
Yeah, so basically, stars far out are going much faster than they should be.
Yeah. You're going too fast.
Going too fast, you slow down.
Something's pushing them.
Slow down.
Something's like, hey, let me take you around. Let me give you a hand.
So if there is dark matter in the universe, then that dark matter is not affected by the radiation in the early universe. And so it's able to kind of clump together and start building those galaxies.
So it could be responsible basically for galaxy formation in the first place.
And so it actually kind of speeds up the evolution of the universe that we see.
Because if it can clump together, then that means that its gravity is pulling other stuff to come together, all that other physical matter or whatever together to then form the stars and eventually galaxies.
Yeah, so we can't look at the universe today and describe it with only ordinary matter.
It doesn't work.
It doesn't work.
You need something mysterious. You need a little extra oomph in there. A little spice, a little hidden flavor.
Technically, a lot of oomph.
Secret ingredient.
A lot of oomph.
It's like the secret sauce of the universe.
Okay, so that's a reference that nobody's going to get except for
my
me.
Family.
Yeah, pretty much. So her dad makes this incredible sauce called secret sauce, and it's really good. It's really good.
So they know it's their Mom, because they can measure the velocity of the stars, and the stars are going faster than they should be, and so that tells them that I keep kicking this thing.
Yeah, okay.
It's fine. It's got the shock
So
thing.
they're measuring the speed of the stars the same way that the cops are measuring you speeding through Bend, Oregon.
My mom doesn't speed.
I know.
I know.
Measuring her and me, I do speed, but so they're using the Doppler effect to measure the speed of these stars, the same way that cops use it.
And they're going, whoa, woo!
Yeah,
woo,
pretty much.
Woo.
And there's a damn thing they can do about it. But when you look at a map of the universe, like we discussed earlier, you can actually see where the dark matter is as those filaments and strands.
Yeah, you can kind of.
As the cosmic.
I mean,
web.
you can't see the dark matter itself.
No. And other evidence is that when we look at galactic clusters, the galaxies are moving a little bit faster than they should be based on the visible matter that we can see. Like we can look at a galaxy and we can get it based on how bright it is and how far away from us it is. We can get a really good idea of how much visible matter is in that galaxy. And so when you do that for example, with Fritz Wiki, when you do that with all of the galaxies in the Coma cluster, you look at each galaxy, you see how bright it is, you have an idea of how far away it is from us. With the Hubble constant, that's where the error comes into effect. You're able to figure out how much mass is in that galaxy. You add that up for each one, and then you look at their speed, and they're going too fast based on, but also you might actually have, that's a single cluster of galaxies, but galaxies like to run into each other. But guess what? Clusters also like to run into each other. So you'll have galactic clusters that hit each other. And there's one called the bullet cluster. Ooh. Well, it's actually two clusters that are colliding with each other.
Oh, that's fun.
The visible center of mass is not in the same location as the actual center of mass, which everything is rotating around. Oh. And so that, and in fact, the disk is very far from each other, which implies that there is a lot of unseen dark matter
there's a collection there.
That center of mass over.
Wow.
Yeah. So we have a lot of evidence. We just don't know what the hell it is.
Yeah. Jack says that Karen, my mother, would never speed. She is chauffeured around while drinking Earl Grey in the back.
Hot.
Yes. That would be her dream.
I want to go back to the day I was born.
Oh, okay.
July 18th, 1969.
Myrtle Beach, South Carolina.
Myrtle Beach Air Force.
That might be too much information to give away. We don't want anyone stealing your identity. Don't say the hospital.
Myrtle Beach, South Carolina. I think I almost said it. It doesn't matter. Anyway, if you would have asked an astronomer, what is the composition of the universe?
Hydrogen, helium, a smattering of lithium, and that's it.
So they would have basically said 75% hydrogen, 24% helium, 1% pretty much everything else. And all of this shit we can see. We can see everything in the universe. We have the potential of seeing everything in the universe.
Wrong.
Fast forward to today.
Wrong.
What is today? Today is March 27th,
2022.
I almost said 2021.
I had some issues in one episode.
Yeah, all right. The universe is made up of 68% dark energy, which we have no idea what the fuck that is.
That's a lot.
27% dark matter, which we have no idea what the fuck that is.
Don't get us started. That dark energy is another episode.
Yeah. And only 5% visible matter.
So basically, the majority of the universe is made up of shit we can't see and we don't know what the hell it is.
Exactly.
And let's hope to Zeus or whatever that it is not the Borg.
My doctor, hey Jack, my doctor had that little long thing,
the Italian plague mask.
The plague mask.
The plague mask.
That was my doctor when I was born. It really wasn't a hospital at all.
They should bring back the plague mask now. It'd be fitting.
That would be. I mean, think about that for a minute. 5%. I mean, when you look out into the world, from here in Bend, Oregon, at your parents' house.
So you're seeing negative a lot to the scientific power % of visible matter.
Well, okay, no, we're not saying a negative.
Not negative, but a point,
But think about it, though. Think about it. When we look out, and just to the world around us, we, especially from your parents' house, we can look out kind of far out. And we see a lot of the world around us. And then we expand that view. Well,
actually, from the top of Mountain Diablo, where we used to live, it had the second largest view in the world on a clear day.
Okay, let's pretend we're on top of Mount Diablo.
Mount Kilimanjaro in Tanzania.
In Alamo, California, on a very clear day.
Okay.
And we're looking out, we can see, 4 or 5 states?
Sure, I don't know what the view range is.
You told me that.
It's the second, I don't know
California, I think you can see, all right. California, Nevada, probably, maybe. Okay, anyway, I don't know. You can see a long way.
You can see a long way.
So you're up there, and that isn't even a fraction of what you can see on Earth. And so you get up on satellites, you can see the entire Earth. With telescopes,
but
you can see.
The majority of the Earth is below your feet. You can't see it.
That's true. And so with telescopes, we're able to see our solar system, our local neighborhood, and we can expand out. And
we can't even spot all the asteroids that are out there.
No, we can expand out and we can see the galaxy. We see parts of the galaxy. We can see other galaxies out there, and we can map hundreds of billions of galaxies along this cosmic web, along the dark matter. All of that shit, all of those trillions and trillions and gazillions of stars and planets that go around those stars, and the asteroids that go around those stars, and
all the aliens,
and all of that, and all the cars that they drive, and the planes that they fly. That only makes up 5% of the entire universe.
Just explosion, but also implosion, and then melting like cheese whiz. 95%
of the universe we don't see, we don't understand.
Know what the fuck it is.
We only see their effects. Dark matter, we see its gravitational effects. Dark energy, we see it trying to just push the universe apart. And we don't understand.
Cold death of nothingness.
We don't understand what either one of those are.
But one day we will, maybe, hopefully.
But what an amazing time to be alive, to try to figure out what it is. What it is. To be honest, 20 years ago, and I hate it when physicists do this. Physicists were like, we're pretty close to the end.
We're done.
We're pretty much. This is going to be like biology, where we're just classifying shit. No.
Biology's still discovering new species just here on
Yeah.
Earth. Yeah, biology's gonna have
But then
a
they
field day
classify it.
when
But then what they do is they
aliens
classify it.
Yeah.
But we still, it's just arrogant. There's so much fucking arrogance in that statement.
I'm sorry. Have you met humanity?
We do not.
Our species is 95% arrogance.
Yes, that's true. That's true. We have not been able to unify two pillars of physics, and 95% of the universe is just unknown right now. And so we have a long way to go. And that's dark matter, everybody. And guess what? When we come back, we have a special guest.
On The Hangover.
On The
with
Hangover,
Cosmos
we have a
Cosmos.
special guest.
But thanks for listening. Follow us on all the things at Drinking Cosmos on Twitter, Cosmos with Cosmos everywhere else. Check out our new short, bite-sized bits of science, shots of science, the shots, coming out every other Wednesday on YouTube and where you get your podcasts. So
It's a lot of fun making those.
follow us
On all the things.
On all the things, and we'll see you
in
next
2
time.
weeks. Cheers, everybody.
We'll see you.
And for those sticking around for the hangover, we'll see you in a couple minutes.
We'll see you in a couple minutes. We'll be back. Special guests. We got a little bit extra setup to do. Drinks to refill. And then we're talking... what did I bring up in the beginning of the episode?
I have no idea.
I don't
But we're going to
remember
talk
what it
about
was,
it.
but we'll talk about it. Maybe we'll also talk about some moon cheese. I don't know. We'll see.
I think that'll be the next episode.
Moon cheese?
Moon cheese. Moon cheese in 2 weeks, everybody. 2 weeks.
Oh, jeez. with Cosmos and as you can see, we have a special guest, my mom.
Yay!
This is the infamous Karen, who asks all the intriguing questions.
Oh, yeah.
Online.
Well, thank you for having me.
Yes, of course. I mean, we're occupying, your house.
Well, this is pretty thrilling. I enjoy your podcast every other Sunday.
Yeah, she has to say that because she birthed me, but
No.
it's fine.
I did not birth him, so
No.
and I say it
It's
to,
by
to
association.
George too.
Jack says
Mike.
hi again. Welcome back, Jack. Glad you stuck with us. In the main
Oh, good.
episode,
Hi, Jack.
in the main
Yeah, we gotta
episode,
get him in
we
that.
talked about what were we talking? We talked about dark matter. I don't know why I keep wanting to say black holes. I did that in the first
I don't
episode.
know. Why don't we ask her what
But
her drink is?
that's what I'm getting to. Since Mom wasn't in the first episode and actually didn't even say what she was drinking in the chat either. What are you drinking, Mom?
I am drinking a primordial black hole.
Nice.
It's ginger ale, a little blackberry bourbon,
Uh-huh.
and I poured some of that bourbon cherry juice in it to make it all dark.
Oh yeah.
So
Do you have
because
some cherries
I'm
in there?
assuming, yes,
Uh-huh.
the swallowed planets.
Yes, they're the swallowed planets of the
swallowed
black hole.
planets. But I'm assuming that primordial black holes are black.
Oh yeah, well we can't really see them, and we talked about primordial black holes in the main episode, so it
Yeah.
fits in perfectly.
There we go.
I love it. Okay, cool. So I can't. Oh, I remembered what it was that we'd go into the hangover for, and then I think I might have just forgotten it.
Okay.
Oh, it was vampires. It was
Oh, yeah,
vampires.
yeah.
Vampires.
Reflected
That's right.
sunlight
Yes.
and vampires. And how come it doesn't affect them? That's
Because
what it
then they
was.
wouldn't live very long. They couldn't live in the day and they couldn't live in the night.
Okay, so it's a literary plot hole. Is
Yeah.
what it is. Okay, cool. All right.
You have to make the story advance somehow.
Yes, that's true. Okay, so question answered. All right, dark matter. That's
All
what we were
right.
talking about in the main
I
episode.
don't know. This is
There was
this
something
is all
else
you.
there was something else that you were like, let's save it for the hangover, and I can't remember what it
did
was.
I?
Yeah.
I don't remember. What
You're like,
do
we
you
can
remember?
talk about it in the hangover.
No, I don't remember you saying it.
Well,
in the
maybe.
podcast.
Is there anything else?
But I had a thought.
Yes.
So
This is why we brought her on here, because she asked all the questions.
She asked all the questions.
So would you consider dark matter like the connective tissue between all the planets?
Damn,
and
that's
stars?
good.
Bringing in her
not
medical
so
background.
much. Not so much the planets, but galaxies.
Okay, so
Yeah.
it's the connective tissue.
Galactic kinetic tissue.
Connective.
Connective tissue.
Connective.
Kinetic.
I meant that. It's my second drink, Mom. I meant that. Galactic connective tissue.
Bringing in my medical background.
Yes. I like that a lot. That's good.
I'm gonna see if I can bring a picture of the cosmic web.
Okay,
Oh,
put it
yeah.
up there. If I have time during editing, I'll put one in the video for later. But I guess that actually is a really good descriptor, because when you look at the cosmic web, I mean, that's why it's a web, you have these filaments and strands that are connecting all the galaxies, galactic. Is it galaxies, or are we at galactic clusters at the cosmic web?
It's pretty much at this point clusters.
Clusters. Okay, so
Galactic
these clusters
clusters.
of galaxies together, and so it
Which
would be like
our
a
galaxy
connective
is
tissue.
one.
Yeah, we're
Our galaxy
a
is a
part,
singular
a part
galaxy.
of a cluster that's
Or
part of
part
a
of a
larger a group of clusters.
Ah.
It's a big cluster fest. The universe.
So,
There's another term there.
It's a cluster fest.
Yes.
so actually, this shows up
that
pretty
shows
well.
up really
Oh,
nice.
it does.
So this is a picture of a
Oh.
cosmic web, and so you can see basically the bright areas of where you are finding all these galaxies and galaxies clusters and galactic clusters, and this is where the dark matter is lining up and connecting. But you can also see these voids where you don't really
yeah.
have anything, so you're not really finding a lot of dark matter there.
Oh.
So, with your analogy, yes, it is the connective tissue of the universe. It is the highway in which everything is connected.
Oh.
Cosmic
Okay.
web. What is that cosmic web taken in? What is it?
This image,
The image.
it better not be an artistic representation.
No, I think I saw it on
The
Twitter.
first image of the cosmic web reveals. This is from CNN, but it reveals hidden dwarf galaxies.
Like
so
what
this
telescope? Like what is it in? What wavelength of light are we
Okay, I'm gonna have to read the article, so you guys will have
It's gotta
to.
find it. Okay, because I'm hoping I was thinking like if that image, it's almost like an X-ray of the universe, kind of on a
Right.
larger scale,
Right.
of course, but
And
seeing the
So
connective tissue.
the images show light emitted by hydrogen atoms. So I'm thinking 21 centimeters. So you're talking radio.
Radio. Okay.
Yeah.
Okay. What looks to be, I was confused for a second because Mom has posted in chat on YouTube, but clearly we can see her visibly right here, not typing anything. So my dad has her iPad and is watching the show.
Yes.
And he says to acknowledge the artwork behind you, which we did in the main episode,
Yeah,
Dad. But
you didn't see it.
Because The Hangover is separate, let's acknowledge the artwork behind us here as one of a Katie Davison
Originals.
you can get rid of me.
Original. You're fine.
You're
Mom.
fine. And by the way, should you want to purchase these?
Well, not these.
No, if you want to purchase these,
She
these
might sell it, I'll tell you.
These go minimum $25,000 a piece. Just hit us up. Let us know.
I thought you were gonna give a realistic price, like $150 or something per.
That is realistic.
That would actually set her up quite well for more art supplies.
You know, some of these images have been shown on a dome.
Well, this one and the other half of it have been.
Have been shown.
Yeah.
Two
And that,
people.
That one's
Yeah.
pretty much my favorite. I
So
love that.
25,000 right here. Because of somebody loving that one, 35,000.
There you go.
Lady Gaga over there.
Lady
Gaga.
Gaga.
That's 50,000.
I'm not a big Lady Gaga fan, so
know.
10.
Oh, okay.
Oh, all right.
I don't know. The
Well,
way
it's all based on your evaluation.
You guys can't see the lips and the teeth in the podcast in the frame, but they're really well done on that painting. Anyway. So we've acknowledged the artist. Thanks, Dan.
I'm just trying to get you guys some money.
Okay, so it's taken the radio, not
She
the
can use
X-ray,
it.
but so we can essentially see dark matter,
You can
but
see
we
the
can't
effects.
see
You see
dark
the
matter.
effects.
It's like how we can see a black hole, but we can't see the black hole.
Right. You
So-
see the effects
Yes.
of dark matter.
So in your illustration,
It was an
they
image.
know that that's dark matter connecting everything, but where there's that void, they know there's nothingness, or they don't know there's
No, you can't say
nothingness.
there's nothingness. Because dark energy, for one thing, permeates the universe. You are going to have gas in that.
But it's so diffuse that you can't really
You
register
might have
it. Like it
you might
doesn't
have
really-
some random stars, maybe.
Ooh, where they've been like thrown out of the
Yeah,
galaxies.
exactly.
kicked
So
out.
from galactic collisions, you can have stars that get ejected out into space, and so maybe through other collisions, you might get planets that get ejected, and so in those voids, you're going to have something. It's just you're not going to find large concentrations of dark matter.
There's not enough of something.
Yeah, you're not going to find, and because you're not going to find dark matter there in large concentrations, you're really not going to find galaxies there. So dark matter, feels it. Not only does it give gravity, add gravity to the universe and attract things with gravity. It feels the gravitational pull from other clumps of dark matter. And so all this dark matter is going to end up in these filaments and strands and that type of
Because
thing.
that gravity just kind of.
Where do the black holes live?
Black holes live in galaxies.
They're all around, hanging out.
Are they
Doing their
more
thing.
in the dark matter parts?
Stellar black holes. So black holes that are created from stars that have imploded exploded, whatever. But it's really kind of an implosion
It's a
process.
both. It's kind of like an implosion
Through supernovae. These are going to reside in galaxies, and so these are predominantly going to be located on the strands of the universe. However, primordial black holes can be anywhere.
Which is what you're drinking. They're in your tummy right now.
Primordial
go.
black holes
With a couple planets.
Primordial black holes could be, right here in our own galaxy, relatively close to us. They could also be in those voids
But wouldn't we be able to see them if they're sucking things in?
And see, black holes don't suck.
They're not always active necessarily. They're not always feeding, is what it's called.
So they're kind of dormant.
You can have ones that are dormant and they're not really. Not a lot
Do
of
we
stuff
know what makes
is close
them
to them to get them pulled in.
Well,
Essentially.
all right. So I think I have to get rid of the misconception. Mm-hmm. Black holes don't suck.
They don't suck.
Well, in my mental image.
Right. And that is actually the stereotypical image of of black holes. Mm-hmm. But what it is all right. So the gravity is always there, and so if you
get too close to it, then
you're
it's like tractor beams, maybe.
It's what?
Like tractor beams? Is that a good analogy?
Okay, all right.
Yeah,
well, you get pulled into it.
You get caught in a tractor beam.
In a tractor beam, you can live through that. And you can't live through the black hole tractor beam.
So it's not a perfect analogy, Mom.
But but if the black hole does not have anything around it, there's no, if it's not pulling gas off of a nearby star, then you're not going to see it.
Because you see the wisps.
Yeah, you see the gas.
There's a lot of
falling
energy.
into
It heats up, and so when it heats up really hot as it's pulling in that material, then we see that radiation occurring. And also, when it's pulling a material, some of it can escape along the poles, and so we can see these jets of radiation. It's kind of like overflow, basically. It's kind of like
that's kind of cool.
Yeah. So what happens is
so
really the gas comes into an accretion disk and it spirals in towards the black hole. But since the accretion disk is made up of charged particles, you can get magnetic fields and they get twisted and all this kind of stuff. And so some of the lucky particles
get to escape.
They follow the magnetic field and they escape up and below the black hole, and these are the jets of the black holes. So it doesn't actually fall into the black hole and then escape through the jets. It's just lucky enough that it doesn't actually cross the event horizon and it follows magnetic field.
Yeah, it gets a nice little off ramp and it's just like, oh!
But most everything does fall in.
Jack says it would be crazy if Gene Roddenberry had it right that writing that dark matter filaments between stars and galaxies was a way to travel faster than the speed of light. This is from an Andromeda short story.
Oh.
That would be cool. But you can't really write it because dark matter is very. It's very dispersed still, right?
Yeah, it's very dispersed.
There's collections of it, but it's still pretty.
And especially if you're talking about particles, it's really small.
Would he be alluding to it creating like a wormhole?
I'm not familiar with this. I'm not familiar with this short story to be able to answer that.
Of course, that's Star Trek, so maybe it's not real.
Well, he's saying writing the dark matter filament. So I'm not really sure what the process is.
As far as getting someplace quicker than.
Yeah, and just remember that warp drive in Star Trek was a plot device.
Yeah,
same with inertial dampeners.
Yeah, but a lot of plot devices, they actually,
a lot of smushed people.
A lot of years later go, oh.
And it wasn't that many years later. I think it was in the 80s they started to figure out at least a theoretical way of doing it.
It gives them something for a goal, right?
Yeah.
That is kind of a trend in science fiction is they think of something like, say, communicators and then, touch screens and then...
computer, show me my day,
Yeah, computer, change temperature. Hey, Google, change temperature. That then people are like, that's a cool idea. Let's figure out how to make it reality.
Right, and science fiction drives, reality eventually.
Yeah, because it's our dreams. So, it's our dreams and our hopes and our fantasies that are kind of, put out there in media.
Science drives science fiction. Science fiction drives science.
reciprocal relationship.
Which then drives engineering, which then makes its way into our everyday life.
I mean, can't you just see somebody thinking, "Ooh, why couldn't we do that? You know, why couldn't we figure that
we
out?"
just got to figure out the physics of, say, replicators.
Well, there
or
you go.
transporters, which
God,
Mike is
no.
not okay with transporters.
Replicators, yes. Transporters,
no.
I am Bones all the way. I will take the shuttle down. You're gonna have to give me a shuttle.
You're like Boromir that won't take the helicopter to go film on top of the mountain.
Exactly.
That's a Lord of the Rings reference.
Yeah. That is true.
There you go.
I forgot about our drinking rules.
We did a lot of Star Trek in this episode references, which is probably why it's not a rule.
So, I mean, transporters, no.
Could we utilize, say we discover what dark matter is there a way to collect it or utilize it in some way that could provide a future technology? I don't know.
I mean, maybe
You
can create it in a lab. I mean, that's depends on what it is. I mean, if it is a particle that can be created through, say, Large Hadron Collider collisions, then you can create it. Now, having said that, the particles need to be stable, which, to be honest, it appears that they are. It's not like we have seen dark matter just disappear.
Yeah, it's not like pooping and popping out of existence. Beep, boop,
Yeah.
boop, boop, boop.
We know that in this epoch of the universe, dark matter still exists.
Epic spelled E-P-O-C-H. Epoch?
Okay.
That's not how you pronounce that,
E-P-O-C-H.
Epic.
That's how they're
Epic.
spelled, the epics.
Yeah.
In this era of the universe,
okay.
we know that dark matter still exists because Vera Rubin showed it 40 years ago, and I'm pretty sure dark matter just didn't pop off in the last 40 years.
No.
Maybe if we discover it's like a particle or something, maybe they'll call them Rubins.
So if we
that'd be
had
another
some type of future electron microscope type of thing on a Hubble or James Webb,
It
where
wouldn't be
you
Hubble.
could approach dark matter and collect whatever those particles
Well,
might
Right, well,
be,
you can't.
Yeah.
If a
or see what we can't see. I mean,
Yeah.
we can't see protons and neutrons and electrons
but they're everywhere.
with our naked eye.
Oh, yes, with our naked eye.
So there are elements
I'm with you
that,
on that.
right, we have had to create devices to see those things.
Mm-hmm.
So there may be some
We
future
need a dark
device
matter telescope.
that
Microscope.
may be able
Microscope,
to
I guess, at that
to
point.
dissect what dark matter is.
Exactly. Well, yeah. I
Is
mean,
there-
once we figure it out, you can always make
I mean,
a
that would
detector.
prove it's there.
I mean,
Because a lot of people are going, well,
Yeah, I mean, to see it, to quote unquote see it, you need a technology detector.
mm-hmm.
And so, yeah, you would put that on a spaceship at some point, and
'Cause I assume there would be dark matter particles, not just say like in the outside of the galaxy or whatever. Like there would be particles, although maybe much more dispersed closer to the solar system, or would they be in the same consistent?
It's gonna be like dark energy, in that it's everywhere.
It's
The
everywhere,
thing is that so if you're talking about particles like quantum particles, it can be right here in this room. These are really tiny, so we're not going to feel their gravitational effects.
Ghosts. Dark matter is ghosts.
Ghosts, yeah. You're going to need
oh
a
God,
lot
we end
of
up there
these.
when we die. Jeez.
Oh, that'd actually, I don't know.
Something comes, our soul.
See the universe? That's fine.
There we go.
Yeah, so you need a lot of these to actually feel their effects.
Yeah.
So you need like a real dense area. Not,
Right. And so we can predict where things will be in the solar system without dark matter's existence. Newton was very successful with this.
So there's most likely not a large concentration of dark matter, say, within the solar system.
There's probably dark matter particles. It's just that there's not enough for us to really feel it.
It's not
Okay,
affecting.
So you need galactic size collections of dark matter.
So when you send James Webb,
It's not gonna.
it's
get
not going to
enough.
go through
It's not
dark
gonna
matter.
Well, it could, but
It,
so
it most likely is,
you'll
but
get
it's
more
not
concentration
going to
if,
feel its
say,
effects.
so you get the higher concentration on a galactic scale rather than the nitty gritty of a solar system.
So when you sent that article about dark matter and it changing the orbit of spacecraft,
right?
I can guarantee you that dark matter is not even thought about with James Webb.
Okay.
And it's not even thought about sending something to Mars, or if we wanted to send something to Pluto. So with like New Horizons, dark matter was not even.
Wouldn't matter if it was visiting the 10C outside of the galaxy, and if you watch Star Trek Picard, then you'll know what I'm talking about.
Yeah.
Well, they were saying that because it has some gravitational.
Right, and so
effect.
over really long
periods. So they're talking
tens
about
of thousands of years.
Well, they didn't go that far, but yeah. So its gravitational effect isn't something that like we feel on Earth.
It's not.
So if I throw an apple up and it falls, that's more gravitational effect than a
That's the Earth. Yeah. So there's
dark matter
there's not a high enough concentration of dark matter for us to even feel it.
What we would call ordinary baryonic matter.
Just those berries hanging around.
Neutrons.
Just the berries.
And we'll even throw some like leptons in there with electrons and neutrinos.
What about muons?
Those muons are baryons.
What about
No, I'm sorry. Muons are leptons.
We might find sterile neutrinos.
We might.
Because how do they figure this stuff out?
How do they reproduce?
They don't. Well, how do they know they're there to say they're there?
Well, they don't know they're there. It's a hypothetical, so it's like.
Or the sterile neutrinos.
Yeah, they're just kind of like.
But you have to get an idea.
Maybe it could be
this,
but
something. There's a seed of something that causes that idea to form.
Right, and so when in physics, what you do is you come up with hypotheses and you test.
In science.
In science, yes, and so and that leads to models of. So your hypothesis really is a model at its basic level, is a model of how something should work in the universe, and you set up an experiment to test it. And so you get bigger and bigger models, and there's a big model called the Standard Model, and the Standard Model is more of a theory now. It's really based on a lot of evidence. There's a lot of evidence behind it, so basically, a long time ago, like 100 plus years ago, they were finding things like protons.
How?
And neutrons.
100 plus years ago, they were finding that
Yeah. So they're finding these things, and
but that was only in the early 1900s.
I know. That's why I'm like, what?
See, when you say 100 years ago, I think of the 1800s.
I know. No, it was early 1900s.
I'm thinking, okay.
I mean, in the 1800s,
and it's done well so far.
It's done really well. But what was going on was that they were discovering protons, neutrons, but then they found all these other exotic type
weird stuff.
Weird stuff.
Strange quarks.
Well, okay, so it wasn't even
that.
that. It wasn't even that at that point.
Taurons, muons.
Yeah,
Geminids.
exactly. And so they needed to come up with a model to explain all this. And so they had hundreds of these weird particles that they had no idea, where they were coming from and all this kind of stuff. And so, but what they were able to figure out over time was that it's really 6 quarks and 6 versions of an electron and a neutrino, and so it can all be boiled down to that. The problem now is, and that became the Standard Model. The problem is these sterile neutrinos don't fall into the Standard Model. And so sterile neutrinos kind of fall into this supersymmetry kind of way, which is kind of you're taking the Standard Model and you're changing it a little bit, but there's no evidence for supersymmetry right now.
But they think that there will be at some point.
No. Not necessarily. The theorists that really believe in supersymmetry say yes, there will be.
What is the
But the
equivalent of
experimentalists.
supersymmetry and string theorists?
What?
What is
Oh,
the
string
equivalent?
theory
What is the
is-
equivalent of the supersymmetry theorists and string theorists?
I think
is there more likelihood of string theory versus?
I think I might be completely wrong on this, but I think string theorists incorporate gravity,
Oh.
and supersymmetry does not.
Oh. Okay.
But
So string
theorists
theory is more plausible.
always believe in their ideas.
Until they have the
Experimentalists
data to...
don't believe in anybody's ideas. In fact, the experimentalists always want to prove
Them
that
wrong.
theirs
Theory's
wrong.
wrong.
Yeah, but in proving them wrong, many times they prove them right?
Well,
Mhm,
I mean, sometimes, yeah. I mean, that's the
But
whole
you have
part
to
of
come
the...
from that.
You have to come,
You have
from,
to
the
come
angle
from that
of,
angle, because otherwise you
Otherwise, you get
slant.
people that cherry pick their data to prove their point of view.
Exactly.
And if
Exactly.
that resonates with you, we wouldn't be watching
Exactly.
this podcast anyway.
Yeah, so the experimentalist dream is to prove Einstein wrong and the Standard Model wrong.
Well, Einstein's been
that
already
is-
proved right in so many.
In
But-
Because they-
100%
you
of the cases, yes.
But Mercury orbits the sun by Newtonian physics.
No, it doesn't.
Oh.
Mercury, I'm sorry. So,
Uh-oh.
I'm just gonna...
no, okay, no, it does. No, it does. It does. It does.
We should incorporate swivel chairs into our normal show.
So
You're going to
it-
take these home in your little car?
So Mercury,
You're sitting on the top.
Mercury has this little anomaly
Uh-huh.
that Einstein, with general theory of relativity,
Oh, so it does Einstein physics.
it does Einstein.
Whereas the rest of the planets do. I just had it backwards.
She did have it
I
backwards.
was
know
on
where
the
you're going.
train.
Yeah,
Just-
but you
in the
know,
wrong
I
car.
think most experimentalists realize that they're not going to prove Einstein wrong. The way they set up their experiments, but when they do, instant Nobel Prize.
That's an
Right.
exciting thing.
It is
like,
a
yes.
Nobel Prize.
Well, can you imagine? I mean, look at what he's come up with, and the age that he came up with all of this stuff. No wonder they've saved his brain in a jar.
I mean, he had time
I
to do
mean,
a lot of thinking.
Goodness, they never saved my brain in a jar.
Does anybody have time to do that much thinking nowadays? I don't know.
No, I don't think it took him much, right?
Oh,
I mean, he was
no.
just coming up with this stuff right and left and drawing it on a chalkboard.
Yes, in
Well,
one.
he came up with
in
a lot of it in
one-
his head.
In one
Yeah.
1 minute montage.
I
That's
know.
it all happened.
So, you know, he probably was an alien.
All right, we've done it right here on Cosmos with Cosmos the Hangover. Einstein
Was
an alien.
He was a resident alien.
Follow us here
That's
on
some
all things,
bullshit.
folks.
Yeah.
Subscribe. Einstein was an alien. You hear it
There
here
you
first.
go.
You heard it here first, folks.
There you go.
You know, he like
He knew
special
more than
theory
he
of
should.
relativity
Jack got
was
excited about my
born
voice.
with the question of what would it be like to go the speed of light, and it was a thought experiment for him. And the special theory of relativity is really built on two things: that the speed of light is constant no matter what reference frame you're in, and that the laws of physics are universal. So no matter where you are in the universe,
You
the
got the same
laws of
physics.
physics are the same.
They're called something differently.
But they're the same.
But I'm just
But-
saying, aliens.
You know, most people never even thought that light had speed.
No, they knew. They knew. In
Not
the
the
1700s.
average person who lit a candle.
Oh, no.
Thought
It was
that
pretty-
light
Come on, we're
had
not talking
speed.
about average people. We're talking
So
about the,
when you
Yeah.
talk about
the
people who
with access
think that
to
way,
education and
Yeah.
books.
that's pretty advanced for the normal population of the time.
Right.
You know, but that was my point.
Rich
Right.
people with access to books and an education.
Yeah, because,
think
you
of
know,
things,
in the 1500s, people just wanted to eat.
Well,
not
yeah.
die
And not
of
get the plague.
plagues and
Well, right, and not have to
childbirth.
undergo surgery without anesthetics.
But Omer, in the 1700s, he was able to deduce the speed of light by looking at the orbits of the Galilean moons around Jupiter. And so he was...
Wow.
Yeah, so he noticed that that the times in which the moons were to be in certain locations were different depending on where we were in the seasons, and he was able from that to calculate the speed of light.
Fascinating. Yeah.
And he was actually pretty close. Just like the Greek dude.
The Greeks that accurately measured the circumference
of the
Earth
Earth
was pretty close to
and it's not flat.
They knew it wasn't flat long before the age of exploration. People,
well,
stop
but
thinking.
the problem is like the Greeks come up with all this stuff, right? And
Up
they
with a
really
lot.
were far advanced. And then it seemed like everyone went back in time.
Well, yes, that's because
we went more primitive.
Okay, short history lesson, just very brief because it's been a long time since I studied history. Romans came along, destroyed a lot of stuff in their takeover. Library of Alexandria burned. We lost a lot of information. Most of all Greek culture and written records were destroyed. And so you enter the Middle Ages eventually once you have the fall of the Roman Empire, and people had to almost start from scratch with learning shit.
And
Let's
that's
hope
the
we don't
history.
have to do
Basically,
that.
we lost a ton of information because of the over extravagance and the basically assholeness of the Roman Empire. I wonder where we can see similarities today. End scene.
There you go.
That is
There you go.
the history of...
Well, that is my Starlink rant.
But you know what flabbergasts me is that we don't look back at that and see our mistakes and not make them again.
Right.
I have an answer for you. It's called capitalism, unchecked capitalism,
Well,
and money.
Well, not so much. I mean, we need to
Yeah.
give up money and all that kind of stuff. I agree.
Caligula-esque person being elected to a president.
I have okay. Yeah, I think that if society were to collapse right now, we would fare better than the Dark Ages, even though
because
we
we still
would
understand the basic of modern medicine.
even though we would still not do very well.
Because we've evolved.
I really think
Not that much,
that
Not that
what-
much, really.
biologically speaking.
Well, how
What
far can we
holds
go
us back?
biologically?
Well, you never know.
You know.
I mean,
we need to. It all
I mean,
happens in our brain,
but
right?
evolution is
Instead
over,
of physically.
I mean, this is the end product of millions of years of evolution.
Yes. So now evolution is developing the parts of brain that we don't understand. I mean, they've already said
what's interesting is
there's 80%
no,
of the
that was
brain.
a myth. That was a myth. That's a myth.
That's a myth. But
That's a
there
myth.
are
We use
parts.
all of our
I mean,
parts.
there
Yeah, we should do an episode on
But
this.
no, but there are
Yeah.
like people who live in like caves or whatever who are now their children are starting to be born with I think it's maybe like I think they're getting like with animals where they have the reflective so they
Right,
have
there's
better
people
night
who live in
vision.
caves?
Yeah, there's like people who live in like yes. And the children are starting to see genetic mutations with their eyes based on the darker areas that they live.
Yeah.
So I'm saying
Yeah.
in another million years' time, which
Yeah.
is nothing on the scale of Earth, but climate change might hinder that progress, most likely at our current rate. But what I'm saying is with another million years, if the planet remains habitable for our species, who knows what biological evolution, you know what I'm saying. What's going to happen? What we could look like.
I really,
You know,
the Vulcans,
physical
Nature
changes,
finds
internal
a way.
changes.
Nature finds a way, yeah.
Nature finds a way.
the
Life
Vulcans need to come.
finds a way.
Please, please, Vulcans, please come. We need to get rid of money and, get rid of poverty and disease. And
Yes, that would be
God.
that would be pretty nice.
I realize that is a different podcast. But
Yeah, it is. It's a new podcast.
Like a hangover.
Evolution, but
we
I
go
think
anywhere.
you know,
Hangover.
But I think that's our brain is basically where we're going to.
Well,
I
our
think-
brain is our I would say like in intelligence evolution,
Right.
So I mean, our brain, say
I don't
over the
see
next
much-
million years, our brains could grow. I mean, if you look at evolutionarily, our brains have grown. We've gotten smarter and been able to make more.
We've had
we
more
could end up with like
pathways.
huge ass heads and like tiny bodies, or we'll just be floating around on levitating chairs like in WALL-E because we don't want to move, just eat fast food all day. Which I don't know, sounds okay.
I want a flying car.
We all want a flying car, Mom, but just think of people who just drive on the ground now. Can you imagine them flying?
Though, yeah, there's an...
no,
flying
with a flying car, you need a force field.
Flying while intoxicated, FWI.
So that they bounce off a force field.
Yeah, let's figure out the fucking cars that are driving by themselves, like, on the road right now.
Yeah.
Then we can get to the planes.
There probably would be less accidents taking the human element out of it.
Maybe it just needs, like, if we just...
Oh my God, but no, there's been accidents.
Well, that's because there's humans.
What if we utilize dark energy as earthly cosmic highways that we can just drive along?
There is a car manufacturer who will remain unnamed, but it starts with a T and
ends musky.
Yes. Yeah. And so they have it where like the car can drive itself, and there was this doctor. He was a fucking doctor.
He took like a nap or something, or what? He was watching.
He was watching TV or something, and the car that he owns that starts with a T, it ran into it was a cop, right? I think he ran into a cop.
But dude,
cop.
Did he run a red light?
No. The cop had pulled somebody over, and so the cop was on the side of the road.
But see, if the cop had been in a car that was actually on its own and didn't have any part of that, then the computer in the test car that starts with a T would have talked to the computer in the cop's car and said, "Oh, okay, I need to do this." I mean, all gonna...
Theoretically, that's what they are supposed to do.
We're not at that point where you can sleep or do something else while driving.
I made a giant leap.
You have to drive, yet you don't have to use the steering wheel, but you have to be...
Yeah, and the company that starts with a T, they do say that, if you're an autopilot, you're still in charge of the car.
Yes, because there are not a lot of autopilot cars around you. And I think human error.
Yeah, and that's why I don't trust it right now, and I would
and you
always
will not
want to
trust
be.
It in your lifetime.
No, I will end up
and
not
definitely not in my lifetime.
In my lifetime,
because I'm a lot older.
You're gonna live forever, whatever.
Oh my God! Don't get morbid with it.
Oh, let's not get morbid. It's my primordial black hole. I am falling in.
Welcome to the Hangover, Mom. Welcome to the Hangover. Falling in. That's good. You're not being sucked in. You're falling in. That's perfect.
Falling in.
You're falling to a black hole.
To my black hole. Yes.
But
I was raised
so.
Your
Your dad's gotten really quiet on comedy.
He really has.
He's watching golf.
He's lost interest and he's back to golf. Yeah. That's usually
he's
how
not.
It is. Anyway, I tried to bring it back to dark matter.
Earlier, it'll never happen. We're in a hangover.
That's true.
We did really great in the podcast where we did talk about dark matter.
Yeah, we did really good.
But now we're in a hangover, so we talk about anything.
Goes.
Yeah, we've covered a lot of subjects.
We've covered a lot.
Evolution, too.
Evolution, electrons, protons, sterile neutrinos. I mean, hey.
You like to come back to those sterile neutrinos.
I think it's fascinating that someone's thought of that.
Why are they sterile?
I don't know.
They don't divide.
Do neutrinos divide? How do neutrinos work?
I don't know. They must replicate some way.
I'm not sure the sterile part.
Because they don't interact with anything but gravity.
Probably.
Maybe? That's why. I think
it's not a replication process.
Sterols are weird.
And that is if they even exist.
So, it somebody's thought of it.
But I
made
think
it a thing.
I really think that in 20 years we might actually have it kind of figured out.
20.
20.
I'm going to be
How
optimistic.
long we've started figuring out dark matter? When did Vera Rubin prove that there was something? Was a matter that was affecting.
Okay, but you have to look at the evolution of computers, though.
Oh well, there's evolution again.
Computers. What is it that law?
But you also have to look at the de-evolution of humanity as we speak.
All right. Well, am going to be.
I'm sorry, the de-evolution of society.
Okay.
Well, we may have robots doing a lot of stuff.
Oh, let's not.
I'm gonna be optimistic.
Okay.
And I'm gonna say, I'm gonna hope that there are gonna be segments of. I'm starting to feel a black hole at this point. There are going to be segments of population and governments that are going to think that advancement of knowledge is a beautiful thing. It is a needed thing.
Yes.
And that
Yes.
we're going to. It is the. I realize that at my core, I'm a punk, and that fuck society in every kind of way. But really, at my core, I'm an optimist, and I really believe that we are going to advance, and that knowledge will overcome. Knowledge is the light, and light always overcomes darkness, and we're going to figure it out.
In order to advance, we have to give up certain long-held beliefs.
Religious
Right?
beliefs. You want me to say it?
She's trying not to.
Well, either that and also autocratic beliefs.
Right.
So,
greedy
we greedy beliefs and
Capitalism.
all of that, and all those kinds of things. And I think that we are going to come to that because life wants to persevere.
Definitely not in 20 years.
No,
I think it's going to take a big.
I think dark.
Yeah.
I really think dark.
No,
matter,
dark matter maybe. I'm
Yeah.
saying society.
Oh, no,
doing
no.
all the things
No.
my mom just said is going
No,
to take
Yeah.
a lot.
Yeah.
I think,
lot longer.
and this is a different podcast. I really think that there's going to be a revolution at some point. We cannot continue down the road that we're continuing, where you have certain people that accumulate wealth at the expense of others, because you cannot hold on to a dollar. That dollar is taken away from somebody else. And so, but at some point, it's going to be a French Revolution, and we know how that ended.
Not well.
We
No.
know
Really
that people got
anybody,
marched
actually.
up to a guillotine. So all of these oligarchs.
Yeah, but it actually ended up reverting back to a.
I know,
I
but
don't know. If that's a good
but-
analogy.
but in that moment though, all you rich people, you lost your head. To be honest, you did. And so I think that these billionaires in the world that have more money than they even know what to do with, they need to take a step back and take a look at the world and realize that how many Einsteins, because you brought up Einstein, or we brought up Einstein at some point.
Yeah.
How many Einsteins are we losing due to malnutrition,
Economic disparity,
due to
racism?
the fact that they can't go to college because there is systemic racism in the world, in this country, that is holding people back. How many of these people are not going to college? How many people are we losing that beautiful knowledge potential that is in their head because they have to go work at a grocery store so that their family can survive?
How many of those have we lost in the past due to
Yeah.
the same issue? How many
Yeah.
serfs could have been like an Einstein?
Yeah.
How many
But you think
children
optimistically,
in a
I think there are a lot
fabrication
of, if there are other Einsteins out there, I don't think we're going to lose all of them. I think that
But one
that-
is too many.
I know.
One is
I
too
agree. But there will be Einsteins that will persevere because they will think ahead of the time.
Right, but they can't get to.
But
I just feel like
you
they
know,
can't
it's
get
harder
to.
to get to where they
But-
can
But that will
utilize
change. That may be what changes things and brings about the change that needs to
Well,
come
we just
about.
need more people that are in positions.
On
of power
another note, I
And-
think
that
that we're
have
going to
a-
probably have a war over it.
Yeah, and this is my opinion. This is not the opinion of everybody else. Yeah, I just money is the root of all evil, and I hate saying that. I really hate saying that.
Well, because we need it.
Well, we need
right now.
We need it. And I realize that I am saying this from a position of white privilege. I have so much white right here.
Wedding ring and
I was trying to go right here. I realized that, but it's white privilege. I live a very privileged life, but there are Einsteins out there that don't have what I have, and they have to go work at someplace to support their family.
I think there are rich people out there who are starting. I think that
I hope so.
There's been a chink in the armor. I think, and it's going to take couple hundred years.
Lot of chinks.
But I think that they're looking, and actually, I think this whole thing with the Ukraine and everything has caused people to start to think. I mean, I'm not an Elon M fan, right? But he set up all those things in Ukraine, the solar things, so that they can have.
I mean, you're not a Who fan?
Elon, what's his face?
Musk.
Well, I wasn't going to say it out loud.
I was going to say that she's not.
But he's doing stuff now. He's doing it because he's getting attention.
Yeah, he could probably end world hunger. So let's not.
Yeah,
right.
Instead, he's launching himself and his buddies into space.
He's
Okay.
all over the fucking map.
But it
has a kid with a weird name.
It only takes a little bit to start the snowball.
Well, I mean, we look at Melinda Gates.
And so
Melinda Gates.
He does
Bezos'
something.
Wife, who
He
donated.
does something good, and no one wants to be outshined, so they do something good, and then they don't want to be outshined, so then they do something good.
Yeah, but here's the problem: we're back to ego by that analogy.
Well,
so.
I know, but as long as they're doing good.
Okay, look, all you Christians that are listening to this, and I admit there might only be like one. But
no,
I don't know that there's are there even
probably
one?
none. But let's be hopeful. I'm an optimistic. I'm an optimistic punk. Look, all you Christians out there that run across this in some way or some fashion, you need to start living your life the way that Jesus told you to live your life, where you start to feed the poor, you feed the hungry, you clothe the naked. Why am I, as an atheist, more Christian than you are?
Because they cherry picked.
Exactly. And so
we're getting down.
My planets are in there.
We're getting down dangerous territory. I mean,
really? Are we getting down dangerous territory?
The episode is about dark matter, and now we're talking about just
Christians are dark matter.
We were talking about.
Well, in reality, Jesus would be quite shocked at where Christianity
Jesus would be disappointed.
He really was.
He's not angry.
No. He was Jewish. He doesn't know anything about Christianity. He just
Yeah, he's like, why isn't everyone Jewish? And what's up with this Hitler guy? What the hell?
What the hell is going on? And why do I have a religion now?
Also, I'm using the word hell, which is Norse. So
now he was a good cult leader.
Oh wow!
I mean, actually.
So yeah, I know, right? So Jesus is like my dad when I would do something wrong as a kid, and he'd go, "I'm not angry. I'm just disappointed," which is like the dagger. It's more that I'd rather you be just angry. Can't you just be mad?
Just be mad
and whoop me?
Yeah.
Because I used to get spankings.
Oh, see, I
would get spankings.
I got grounded.
I got spankings.
Yeah, go get.
But I'm a lot older than you, and it was more,
social
prevalent.
Acceptable
It was very social acceptable to beat your children.
Was I ever spanked? I don't recall being spanked.
No, I didn't do that.
No, you.
No, I grounded you.
I got grounded.
Really, I really don't see you or Katie ever getting spanked.
No.
And I say that I've been spanked. It's not like it was every day.
No.
It was very rare that I got it. But the worst thing was go pick out a belt.
Oh.
And
see,
then
I never got that spank.
I would have to make the long walk to get a belt.
Choose wisely.
And then you have to.
Choose wisely.
This is the lesson. This is my first lesson in physics.
A feather belt.
One of those ones that's like the different one of those ones
Pool
that has like
noodles.
the holes in it that has like the different little leathers woven
No,
together.
I didn't get. I got pushed through a screen door one time.
Oh, shit.
mouthing off.
Papa didn't do that.
Yeah.
Okay, I don't want to talk about this anymore.
No.
Don't ruin my vision of
But,
Papa.
you know, it was one time in my
although, to be
life.
fair,
I'm 69.
After working in a preschool,
Wait a minute, how old were you?
It's kind
How
of-
old were you?
There was a couple that
You
I
know,
was like,
you did
"Oh."
push us to a limit a couple times.
Oh yeah, I was rough. I was a
Yeah,
rough
you were
girl.
rough. Katie was like,
Katie
oh
was a
no,
mean
I'll
girl.
never do it again. Elizabeth was like,
That was rough.
yeah,
Let me test it.
maybe.
Let me check
You were my
this out.
Malamute.
We have gotten no more comments.
Fluffy.
So I'm
No.
pretty
Well,
sure
Dad's
that...
still watching.
Everybody's
Dad
left.
was still watching until we went into like the race
Oh,
tirade.
I killed your audience.
Until we went to critical
No,
race
you
theory.
haven't. It's just that we've gone down so many
this is
rabbit
our
holes.
norm.
Yeah, we've got
Anyway,
a lot of rabbit
alright.
holes. A hangover.
Closing it back in.
So let's
Before
get
we
on
get to
another...
dark
Dark matter.
Dark matter, prevalent. Can't see it. Don't know what it is.
Connective tissue
Um,
to the
Universe?
universe. Stop being racist. Rich people contribute more to society. You live in it too. We got one planet to live on. That's all we got. Let's make it last as long as we can until the sun burns out and swallows us whole. And that means smart people, Einsteins, come out. We need warp drive immediately and replicators or Vulcans, please.
Yes, I want to go up and
Please
say,
come.
No
Give me dinner.
transporters. No transporters, though. We don't want
I'm
those.
fine with transporters.
I am too.
Really? It would just...
Yeah. Look, if I come out wrong, just reverse it. Like, transport me
You
back.
can't
and
reverse it.
You can do some. Look, O'Brien could do some shit, and he could fix the issue.
No.
All right? As long as I got an O'Brien at the helm, the transporter helm.
you
not
know-
the...
They have a thing called Heisenberg compensators for a reason.
Look, I never watched
But-
Breaking Bad.
Which is what? No, they're trying to overcome the
I have no
Heisenberg
idea.
uncertainty principle. That is what those things do.
Oh, okay.
Until they can show me
I'm
that
just
those
saying,
things work.
I'm just saying. I'm sure once they're
You know
mass
what?
produced, then it's gonna be fine.
It's going to be several hundred years.
Oh yeah, it's gonna be a long time. We're not.
But-
we're not.
but they
anywhere
And you
do
near
say
it.
I'm optimistic about Dark Matter.
They will do it.
Well, let's get through Ukraine first.
Yeah.
Without having World
I
War
agree.
III.
Let's get through COVID and just I don't know, maybe the next 5 years at least.
I wanna get
COVID
through
was
spaghetti.
just like the flu.
Anyway, this was a fun episode.
It was fun. Thank you for
It was a
having
lot
me.
better. Thanks for joining us.
I
Mom.
enjoyed it.
It's been a pleasure.
It may be several hundred years.
No.
So you're back on the episode
I think
show.
in 2 weeks you should show up in
Let's just-
Ogden
yeah.
for-
There we
We'll
go.
see. I mean,
I will bring my Aussies.
now we know we can record when we're up here visiting if we need to.
Yeah.
So
Come
we'll
lots.
Do that. Yeah.
Yeah.
We'll get the game
Jack has
together.
enjoyed podcast
Okay,
Jack.
I looked over at
Well,
Dog Jack.
Our Jack over there.
Here, I don't know if you guys can see the. Oh no, the
No,
exercise
we got
mic
the
is in
bike.
the way. There's two
I-
lumps over there.
There
I
are
see
dogs.
Asa.
There are
I
dogs.
see Asa, but
Yeah. Jack is always with Asa.
Anyway, thank you guys for joining us on the Hangover with Cosmos. It's been a typical hangover
And Karen
wild ride
Davison.
featuring the one and only birth mom of yours truly, Karen.
You will see me on
Davison.
chat
She'll be on
in
chat.
2 weeks.
Join us next time and follow us on all the things at Cosmos with Cosmos everywhere except for Twitter, which is at Drinking Cosmos. Check out our new episodes of The Shot coming out every other Wednesday. Short, bite-sized bits of science. That's fun. But for now, thanks for joining us, and we'll see you guys around next time.
cheers, everybody.
And bear
Stay
with me.
safe, stay healthy.
It's going to take me a bit to shut this down because the table's really far away, and I gotta manually do this. So,
But you're
thanks
so
again.
talented.
Oh yeah.
You're my daughter.
Bye everyone. Bye,
Bye.
Jack. Bye,
Cheers.
Dad.
See you in 2 weeks.
Cheers.
We're almost done. Hold on. There we go. Okay. We're